Yes, okay.
Okay, but because one of them is pointing to the ceiling.
The ceiling.
Yeah, I would turn off the
camera. Okay.
Okay.
Hello.
I heard from Bob, but he will come online.
Who?
Bob. Robert. But we talked yesterday. He asked about the link, and I sent him the link yesterday. So I mean, he's aware, but I haven't heard from him since. But it's minus 6 hours over there, or 8 hours. So I guess it's morning.
All the presenters who are connected are also activated. I see Nicola Masi just joined us.
Yes.
I have to, but I don't see him in the list. Okay, and now I see him. Good evening, Nicola. Just in case you want to say something at the end, I activated you as presenter.
Well, how is weather? Rome, is it good?
Pretty summer-like weather.
Ok.
Ciao Pino, buonasera, ben trovato. Un attimo che ti abilito,
E Luca, Max, com'è il tempo a Luca? Microfono staccato.
Sì, è bello, abbiamo un po' di vento, un po' di sole, un po' di nuvole.
Io sto chiamando da Atene dove ci sono 30 gradi meravigliosi.
Fantastico.
Ora Peter.
Ciao Guido. Come va?
Bene, adesso bene, tu?
Sono in barca. Sì, sono in barca da te.
Ma sei solo, no?
Sì, sono con i miei compagni, siamo pronti per partire domani per rientrare in Italia. La porta la Spezia la barca.
Ma quello che era te cos'è? Un Elf?
La sono? Sì.
Io ce l'ho più piccolo per l'aereo.
Questo è un po'.
Chi è che ha l'aereo? Non sentivo.
Io?
Cosa?
È un Tairona, un MX-1000.
Anch'io sono un pilota con un design inglese.
Sì, ho visto, ci siamo incorsi nei campi di volo. Io sapevo di te già da prima, però non ci siamo mai incrociati.
Ma questa è l'occasione buona, dai.
Tu pensa, io lo raccontavo a Cristina, nell'80° ho fatto un annullo postale in volo, partendo da Roma fino a Francesco Baracca, a Treviso.
Bellissimo, bellissimo. Guarda, tra l'altro sappi che avevamo fatto una mostra a Trieste nel marinari, i dirigibili, e avevamo fatto un annuncio speciale anche noi, quando sulla mostra sui dirigibili, una cosa più unica che fare ormai. Ma comunque l'Oscar poteva fare sicuramente parlare non ci sarà più la posta, però ci sarà.
Antonio?
Eccola. Antonio, non lo so se lo vediamo entrare, lo abilitiamo, ma in questo momento... Ah, eccolo Antonio, perfetto, lo vedo. Antonio, benvenuto. Sei abilitato, dovresti poter attivare il microfono.
Sì.
Possiamo iniziare? Sì, Cicu, you are the boss. You are the boss. Tell us.
I believe that we could start. And of course we can always say that we need the 5 academical meetings in order to get some more people. I cannot see how many are picked up now, but eventually you could do so. You could tell me how many are they.
I can let you know, Julia, how many people do we have connected at the moment? I think it's about 22 on this channel, plus the 2 Facebook connections.
Okay. But I presume we could at least start. You can start.
Okay.
Luca, and then we can go slowly forward until 5 minutes time. We will, in addition, have the introduction of Her Excellency the Ambassador.
Okay, absolutely. Okay, so good evening, everybody. It's a pleasure to be here with you today for the final webinar of the 95 years ago, the Norge webinar cycle. This is an international initiative within the Shadow of Norge project, promoted by GREAL of the European University of Rome, the Italian Geographical Society, as part of a very large, and we are very, very happy about that, institutional network, including several institutions in Italy, Norway, Russia, Great Britain also, and basically all the countries which were involved in the Norge expedition in 1926. We will present today, so far we have discussed several aspects of the Norge expedition and its geographical, historical implications. And now we are going to look towards the future. We're going to speak about new opportunities which basically come from the heritage, the legacy of Norge 95 years after the expedition. We have invited Her Excellency Dr. Margit Tveiten, the ambassador of Norway to Italy, and she had gladly accepted in the beginning, but then she had another commitment of institutional nature, but she wanted to still be with us today. So she sent us a video that I would like to show, an introductory video with a greeting from Norway. That is the country that first wanted the Norge expedition to be organized in 1926. I'm going to now show the video.
Ladies and gentlemen, signore e signori, Mr. Chair, speakers, participants. I am very honored to have been asked to open this concluding webinar celebrating the 95th anniversary of the Norge expedition. The Arctic is part of my identity as a Norwegian. Norway is an Arctic country, and the North Pole does not seem to be as far away. Well, I've not been there yet, and it is not so easily accessible. Our polar identity is to a large degree linked to Norwegian explorers who went there. Roald Amundsen was probably the first. This makes us proud, and it has inspired newer generations of Norwegians and others to follow in the footsteps of our explorers. Norway and Italy are closely linked in polar research and in our history of explorers, both in the past and in the present. It is what we diplomats call an important bilateral link. We are very happy to tell the story of this link, and the Norwegian Embassy in Rome works on the Arctic relationship between our two countries. As Norway's ambassador to Italy, I have had the pleasure to cooperate with many of the Italian institutions participating in the commemoration of the 95 years since the airship Norge flew over the North Pole. I am truly impressed by these webinars, which have been organized in April and May this year, celebrating the historical achievements and presenting science-oriented seminars for polar exploration. It is important to keep telling the story of Amundsen and Norge and inspire future potential polar explorers. Today, May 12th, is the exact date when Roald Amundsen and Umberto Nobile flew over the North Pole. They shared an adventurous spirit, and their courage and strength brought them together on this journey towards unknown lands. 95 years later, and the adventure continues. I know there will be interesting presentations today, and I am glad to know that Petter Johannessen will guide you through this exciting evening. Thank you.
Thank you. We are very grateful to the ambassador for this introductory greeting, and I would definitely give the floor to our chairman, Dr. Petter Johannessen, who will guide us in this webinar.
Well, Danica, thank you. Thank you very much for, first of all, for the initiative and the initiatives that you have taken to organize all these webinars in relation to the celebrations of the 95th year anniversary. Can we say that? You can say that. That the Roland and the Norge and all the crew members of Norge did fly over the North Pole in 1926. What does it mean for us, the North Pole? It means a lot of things. It is the attraction of everyone who has some sort of desire of exploration in his mind or in her mind, that is to go to the North Pole. North Pole is the attraction of everyone who really loves to try the extreme experience. And being let's say, a relative to Roland, I've explored myself twice, and I've been there on 2 occasions, and those were incredible experiences. But we want to talk a little bit more about Roland, and then, of course, that Nobile and the Norge as such. Norge is a symbol of what Roald had in mind. He had one note that he used to say, I use the state-of-the-art technology to do my exploration. I'm not running for something unique. I'm using the state-of-the-art technology. And in order to do that, of course, he went to the South Pole with boats, because there were no other means that some other tried courses, Siberian courses, imagine, take courses to the South Pole or track tractors that drowned the first time they lifted the tractors from the ship to the ice. They fell and sank immediately before it touched the ice surface. And that is of course, human planning, programming, way of thinking. And that is something that Roland had as a sort of mantra. He said that, of course, unsuccess, that is, it is failure. They call it luck. And success, someone call it luck. And he confirmed that if you do prepare yourself, if you do the good planning, the chances to be unsuccessful are very small. So he fought a very big struggle during years as explorer to plan as detailed as possible his exploration. But I don't think we're going to talk, many of us. I would like, I think, Gianluca, you are the first one to talk, or Luigi Paolo, that is the first one to talk. I don't have the agenda here in front of me, so you must help me.
I think it was Max, basically, and then Carlos.
Okay. But, so then I don't want to cut the talk of Roland, because I could talk of Roland and his explorations for hours if you want to. But I think that it's worthwhile having other views, and since this is the theme of today's webinar is called North Pole and Beyond That, I mean, we must talk about the future. How can we see the North Pole as an instrument of many things, not only using the history, which is important, fundamental, looking backwards only as a mirror. We can't turn around and look back. We can look backwards by using the mirror of history. So I'm very pleased that Max can take over the show, and it is yours, my dear friend.
Oh, okay, thank you. I'm really glad to be here, to be invited on such an important day of the history of polar exploration, and especially history of. I love everything that flies, passion to be something magical, something beyond the normality. So such a big dream of flying the biggest flying object ever. So I think the first here to introduce is North Pole and beyond. I start from the past to give them space to Karloska and to the next presentation to talk about the contemporary activity, and then to talk about the future of airships. Obviously, I'm starting from the past. This is what I love. I mean, it's the past of this strange, let me say, strange idea of reaching the most remote place in the world by flying objects. We know that, I mean, the North Pole has been always always attracted people, explorers, and now I want to make a very short talk about how this LTA, lighter than air technology. Just 1 second, I'm showing the. Okay.
Yes, we do.
Perfect. So, okay, today we're talking about the Norge, and the Norge is a symbol of this the exploration. But I mean, the idea of flying above the North Pole started earlier, and we know that the very long trip that Norge did in 1926 was already just one of the exploration that involved airships in the North Pole. So I want to just try to understand about these explorations, what was innovative for their times, and what was what we can have today as the legacy to start again exploring Arctic by airships. So this is that timeline. Timeline was populated from the end of the 800s to from the 50s of last centuries. So let's start. Okay, Salomon and Ray. The first to try with the balloon, it's not exactly a mesh, but they tried to add to the balloon some sails and some instruments in order to be controlled during flight. Unfortunately, they failed right after the start of their exploration, and they survived the crash. They survived the forced landing. Unfortunately, they died after a long period on the ice. And these beautiful pictures were found again after 33 years. So it's amazing to see these pictures. What was the innovation of this idea by André, the Swedish engineer? The fact that he used hydrogen instead of hot air, the fact that he tried to introduce a system for altitude control, the fact that he introduced the idea of having sails to steer the balloon, and they were equipped in a very good way. They had the possibility to survive for months on the ice, but they only made really 250 nautical miles, nothing. In the 1906, 07, and 09, Walter Wellman, American journalist, tried with a French balloon without airship. This was called sort of a primitive with the airship. However, they tried and they fed 3 times in a row. And probably it was too early, and the technology was not enough developed. However, they brought some interesting innovations. They put 3 engines in their ship. They made finally crew accommodation in order to protect the crew. They introduced as for ships, however, the first system for controlling the direction and altitude too, a sort of a strange machine called equilibrator, but they failed 35 nautical miles. So we have to wait until the 20s, when in the 1923, the US Navy tried to use their best airship, the USS Shenandoah. The Shenandoah was a very interesting ship because was some copy of the German conquer of the First World War. However, it was also the first airship filled by helium. So the strength of this airship was the fact we had a rigid structure, multiple gas bags, a lot of engine, 6, and the possibility of flying very high. The idea was to make very long, to 11,000 nautical miles, but this exploration never started because of an incident the Shenandoah had, and then finally after this incident, unfortunately, it crashed during the thunderstorm in the States. So they had to give up the idea of a polar exploration. So now we are in 1926. The day we're celebrating the M1 by Nobile with Amundsen, Ellsworth, and Nobile in their exploration. We perfectly know this is I think the 4th webinar about this day, so I don't want to talk about Nobile, but I want to just put on paper the ideas that the innovations that Umberto Nobile put in this action. The fact that extremely rich structure, more flexible, less rigid, probably, so giving to the actual better maneuverability. The top speed was quite high for its period, its time, and the mooring equipment, there was a great innovation to moor to the North Pole, and to Vazzo, and to Oslo, in order to use the mooring mast as to traveling phase. And finally, the flight was very long, 7,000 nautical miles. Right after the 2 years after, when Nobel really tried with the famous or intense flight of the N4 Italian. The N4 was basically an improvement of the N1, but again, thanks to the experience of the first flight, Nobel introduced the other interesting technical solutions. Like he strengthened the cover of the ship, he put an anchor, and this is interesting for landing, because it was the first time they planned to land to North Pole. And this is something that is, for the first time, they were trying to have a stop there. Unfortunately, we know that they didn't succeed. They reached North Pole, but they didn't land and they crashed on the way back. However, again, the portable emergency radio is another great innovation that saved the life of many, of many survivors of the accident. Finally, they brought a lot of equipment for exploration because the idea was to stop and to explore. And scientific equipment, again, because Italy was intended more like a laboratory, flying laboratory for the Arctic region. 6,700 nautical miles with a very sad end, unfortunately, but a great performance. Again, in 31, the most famous probably airship ever, the Graf Zeppelin, flew to the Arctic for a sort of a scientific exploration. In reality, it was even more, I would say, even more peculiar, because the idea was to fly to the North Pole and to meet there a submarine led by an Australian Wilkins, an Australian explorer, and there was two meets at the North Pole, one above and the other below the ice. Unfortunately, the submarine failed, had to stop in England and then in Ireland and Barbary Islands. So they decided to make an exploration of the Arctic region, and they flew in the unknown lands like the Franz Josef Land. And these images are fantastic because they flew there, they exchanged the mail in the Arctic, in the Google island of an unknown land. And in this airship was flying Ugo Eckner, basically the father of Zeppelins, the father of basically all the airships. Simonovich, a Russian scientist, and Ellsworth that flew with Amundsen and Nobel to North Pole. And here, in the boat, we can see in the foreground, was sitting Umberto Nobel. So imagine to be in the Arctic, 900 kilometers from the pole, and to put together in one place all these great explorers and these great scientists. It's an amazing moment. What Eckner brought to the innovation? First, use the rigid construction, then to use a spacious passenger cabin. And this was interesting because it was the first time people were doing sort of a touristic flight to the North Pole. Then they were equipped in a very good way, especially after the tragedy of the Italia. And they were carrying a lot of scientific equipment, and they transformed the airship as a flying laboratory. Then again, they had the electric kitchen on board, fantastic for this kind of place. And they made more than 7,000 now nautical miles. Uh, I mean, less known is the story of another airship by Bertanoville, he designed for the Soviet Union. This is the V6 Ozoviakin, and was his, the last airship designed by Nobile, and this airship was sent to save a polar expedition led by Ivan Papanin, who was lost on a floating ice island near the eastern coast of Riga. They started from Moscow, but unfortunately they crashed near Murmansk. However, the idea was to reach the Greenland to buy ash. And the innovation of this beautiful Rosoviatin airship was a new gas valve system included 3 layers of envelope and the increased endurance and the enlarged cabin. So this is, probably the last known flight to the Arctic. But I want to remember that in 1958, the U.S. Navy sent another interesting airship, the ZPG-2 class. Was a blink, not a rigid, but a semi-rigid airship. So without any structure inside. And this airship was quite famous because it was becoming directly from the airship used during the Second War. And this airship called Snowbirds was sent to the Arctic, to the north of Canada, to the Northwest Territories, and fuel made a very long trip for a blink, more than 4,700 nautical miles, introducing again something interesting, like using a very efficient system of propulsions, a very rational on-board accommodation for the crew, high maneuverability for landing. This is pretty important for this kind of exploration, an excellent range, and especially galley and food, special food on board. So this is the story. So what we can nowadays, what is the legacy of these explorations? So basically, we can now have a list of things that can be used for next exploration as a starting point. They demonstrate that an excellent range and high speed were very important. High speed for airships, obviously. Low consumption is mandatory. High maneuverability both in flight and for landing. Mooring equipment and anchors for landing on the ice. And especially capability of landing without assistance. Then for the crew and for passengers, rational onboard accommodation. A lot of place for the passengers, kitchen, and special food, equipment for exploration, and especially for the safety equipment. So all these things are now in my next edition of my book, and I made a specific edition for the North Pole and for North Pole West. Okay, that's all, and thank you for listening, and I hope you enjoy this presentation.
Thank you very much, Max. It is very interesting. Rolling up the history, this way, by telling us and informing us what has happened in the history related to airships is extremely interesting because it is the platform for what will happen in the years to come. So I'm very impressed. I have to admit that I didn't really know all the details, and very, very interesting. Therefore, I'm now passing the floor to Karoskar, and I do believe that Karoskar can tell us a bit will happen in the future?
Thank you, Peter. So, my name is Carl-Oskar Lavacek. I'm one of the founders of Ocean Sky, and our vision is to make aviation clean and sustainable, and our mission is to bring back large-scale airships because they are the most efficient aerial vehicles that we actually have. The presentation, Max, will you get the presentation up?
Okay, can you see the screen?
Now, yes, and I ask for control. Okay. Perfect. So, as you already know, of course, the starting point. Okay. There we go. As you are very well aware of, the geographic North Pole was first explored or reached in 1926. And it was obviously the Norwegian explorer Amundsen and the Italian airship designer Nobile and the American tycoon and inventor Ellsworth that reached the North Pole in a semi-rigid airship named Norge. You are also probably very aware of that these historic airships were not able to land without a ground crew, or at least they had definitely difficulties in landing without ground crew. So what they did was instead they could overfly the North Pole. Today, with new technologies and new materials, there are things we can do that was unthinkable back in 1926. And what the future holds for these, what we say sometimes, gentle giants of the sky can be quite fascinating, considering their super efficient green profile combined with the comfort that they can actually offer. So Ocean Sky go-to-market strategy and first milestone is to show the world the magnificent capabilities of modern large-scale airships by demonstrating a season of expeditions to the North Pole. And we'll do this in the world's largest flying vehicles, modern airships, which are being constructed in several different places around the world. The purpose of these expeditions is to usher in an era of clean and sustainable and obviously comfortable and quiet way of traveling, using state-of-the-art technology and engineering. Slow and low without leaving a footprint. Imagine floating over frosty landscape some 100 meters above in comfort and in silence with panoramic windows. This would be quite spectacular, and to do that with a purpose fulfills the mission of Ocean Sky and can be the first cornerstone in providing the world a sustainable way of traveling. Okay, but first, let's step back from North Pole in 1 second and just remember what the world once saw was a golden era of airships. It was not just Norge that went to the North Pole. It was an enormous amount of airships flying around in the 20s and 30s and actually on schedule delivered passengers across the Atlantic Ocean. And it's quite incredible that this industry just disappeared because of the famous accident in 1937. They connected our continent and transported thousands of passengers. It was the elite of businessmen and famous names that used the German airline of airships to travel, and predominantly between the US and Europe. Even a round the world tour was successfully completed in record time by the famous Graf Zeppelin in 1929. Could we be at the point where this era could be restarted? An airship revolution in aviation? Well, we believe so. Ocean Sky and its sister company Ocean Sky Cruises comes from aviation in VIP jets and cargo airlines. Our company was established in 2014 and launched the pre-ticket sales on Earth Day in 2019 for our first journey from Svalbard to the North Pole in the footsteps of Amundsen and Nobile. Our vision is, as we say, to bring back the airships, and by doing that, we believe that we can offer truly sustainable way of traveling because of airships' efficiency, many times more efficient than airplanes, and can pretty easily be non-fossil dependent because of the low power requirement that they actually demand. And as we know, the climate is experiencing a rise in temperature that we know brings two sudden changes for wildlife and humanity to adapt to. We're facing a real threat in the continuation of using fossil fuels. If we don't act swiftly and decisively now, we are probably refusing our children the same opportunities that has been taken granted for previous generations. But I'd say there's hope. Initiatives around the globe are in full motion now to turn this development around, and being part of it is in itself inspirational. But like we always say, let's not forget that the biggest threat to our planet is the belief that someone else will save it. The famous quote from our endorser and collaborator, Robert Swan, that was the first man to walk the South Pole and walk the North Pole, which will join us to the North Pole in our airship in a couple of years. So, why can airships offer sustainability? In order to be sustainable, sorry, I'm trying to shift slide here, but it's a bit stuck. Let's see. Max, can you help me shift the slide? I don't know why.
Right second. Okay, good.
Okay, here we go. In order to be sustainable in the true essence of the word, we need to focus on preserving our energy supply. I'm talking about the world's energy supply. We must not use more energy than we can sustainably harvest. Today we use the resources of 1.5 planets per year, so it's clear we need to reduce our energy consumption, our total energy consumption on Earth. The key here is to focus on energy efficiency. How can we do what we need to do to the least amount of energy consumption? The bad news in aviation is that the equipment we use today, airplanes, is extremely inefficient. Airplanes are rockets with wings that require tons of metal to stay airborne and push through the sky at 900 kilometers an hour. There's nothing efficient about that at all. It's a rocket. The good news is that there is massive energy saving potential in aviation. So airships can save a very large portion, maybe 50, maybe 60, maybe even 80 or 90% of efficiency in different development cycles, obviously. But 50% is quite easily achievable. Then obviously we need development cycles to reach higher savings. But we're talking about a fraction of energy. But also what's interesting is that the remaining energy that we actually need for airships as well, the remaining energy can be zero emission fairly easily because we have the space to provide for other types of fuel and other types of energy carriers. And this is very interesting. Fossil fuels are very energy dense, and it's hard to just swap fossil fuel to something else. But with airships, we actually have a fair chance. Airplanes are difficult to make non-dependent from fossil fuels. They need an extremely high amount of energy density in the fuel, both to save weight and volume. Batteries, for example, is not available for the foreseeable future to exchange airplanes in that kind of range. And they're not, because they're not able to deliver the energy density in the level it's required. Biofuel is not able to supply even a fraction of the fuel needed if we're talking on a global scale. But large-scale airships offer technology that is actually readily available today with today's technology, and when commercially proven, can offer a very energy-saving potential in aviation in probably the shortest time horizon compared to any other option. Modern airships offer an opportunity that historic airships could not accomplish because of the new material, because of the new design, because of the new technology. So airships can basically land anywhere without ground infrastructure, without people and machinery to secure it. The last 20 years have been groundbreaking in the light of an air industry, creating, for example, prototype vehicles of full size with the ability of great range and endurance, and also the possibility to land on any reasonable flat surface. So why do we need to go to the North Pole? So the North Pole, the polar region, so the North Pole is ground zero for climate change. What happens here predicts the climate's future elsewhere. The North Pole is regarded as one of the most inaccessible places on Earth, a geographical location defined as the axis the world spins. Located on a large mass of ice floating in the Arctic Sea, there is no better destination to show what an airship is capable of, we believe, where other modes of transport can't deliver or use excessive amounts of energy or time to reach. To do that, to reach the North Pole without fossil fuel would mark the beginning of a new era of aviation. It would absolutely be enormous because aviation is $1 trillion industry. When we show the world the capability, the capacity and potential of LTA or lighter than air technology, and we then offer an alternative to fossil fueled aviation and open the eyes of consumers, industrialists, politicians, and world leaders. Not only will we fly and land on the North Pole, we will do so in serene comfort. A quiet cruise with unprecedented views from panorama windows and in wildlife spotting friendly altitude as we fly very low and very slow. And you can even dine in a luxurious lounge the same time. And of course, you can have your own cabin because space is abundant. So you will have a comfortable resting place, private suite. This way we will show what travel is really about, where the journey is a destination, and passenger travel is healthy, revitalizing, and comfortable. Airships also actually offer a good safety potential. First of all, it has redundancy of engines. Usually airships never come with less than 4 engines. So we don't have to worry about losing an engine. With airplanes, losing one engine, if you have two, it's quite serious. It also have a safety potential because of the low speed in landing and takeoff. Imagine having an accident in 20 knots compared to having an accident in the landing phase in 120 knots. Quite a big difference. Also, probably in the future, airships will offer private cabin and space. This means we can offer pandemic-safe travel options. You don't have to sit right next to your passenger, your fellow passenger. So, I mean, mankind will not stop travel and transport, even if it hurts our planet. We will continue doing what we need to do. We need to transport, and we want to travel. So, travel has increased year by year until the pandemic, basically. Therefore, we think we have to find new ways to do it. We are pushing for a change in travel psychology, not only to do it consciously and responsibly, but also to reduce overall travel by increased quality and decreased quantity. Because this is actually how you emissions the most. You actually do it less. So we basically need the free thinkers, the visionaries, and the idealists, and the pioneers to come together and push for this change. And Ocean Sky, we try to contribute with it as a piece of the puzzle that we think is missing to create a game change in aviation and in travel by creating this North Pole expedition as a first expedition, obviously. Then it will be many more after that. And by doing this, we are building a business case. We are showing the capital market that there is profits to be made. If you have a sustainable product, if you're using lighter than air technology, you can actually make money. Because this has been a major issue for the lighter than air technology industry. It has been underfinanced for many, many years, living off of military budgets instead of private capital. When private capital comes into the picture, things change. Things speed up. Things start to happen extremely fast. And they multiply. And they scale. If it's successful, obviously. But we have proven that this model is successful. And that's really interesting. Because now private capital can engage. So, to create a paradigm shift in aviation, we challenge the basics of traveling. We show what is possible. Even 100 years ago, it was actually possible. But now with modern ultra-light, ultra-strong materials and state-of-the-art engineering and design, And never before it has been possible to look out such sizable windows in a flying yacht or a flying hotel, quietly propelling itself, gracefully floating in the air, or into the future of aviation. Never before it was possible to point out the window and say, to any meadow, field, or lake, and say, let's land there. Let's just land there now. That is something completely incredible for a pilot. I never said that maybe, but I'm a commercial pilot by trade. And this is, you have to go from airport to airport. It has to be completely planned. It has to be, of course, but with an airship, everything changes. It's really a part of creation of history. And history obviously is written page by page, and we think the first step in this change is to bring a large-scale modern airship to the North Pole and land there in the footsteps of Nobel, Amundsen, and elsewhere.
Time is running out.
Yes, finishing. So the proof of capability, once operational, will probably create the demand, which will be met with building larger and many more capable airships. And when there's an alternative for humanity to travel in a different way, we think absolutely. When that alternative exists, we think the change will happen. So why wouldn't this scenario of a futuristic airship travel come true? We have the knowledge to build these ships. We have the technology to construct them. We have the experience to operate them. If we are serious in bringing zero-emission transportation to the world, I'm afraid, or actually I'm happy to say, that airships might be our only solution. We believe mankind can overcome this great environmental challenge we are confronted with and create this world where we can live in harmony with nature and each other as well. So we offer this flag bearer to offer a new a change. This flag bearer could be actually airships. Thank you.
Well, it's exciting. I am thrilled. Personally, I do hope that this thrilled way of presenting things is contagious, and I do hope that Void is available and
Problem, unfortunately.
okay. So what I will do, if you could eventually take action with him, call him or get in touch with him, I will give the floor to Gianluca, and Gianluca will then take us back to not only history, but what airships can be used for, not only for passenger transportation, but in the research environment and as a research instrument to have a better life for our children, since we have done what we could do to destroy that earth. And I would like to pass the floor to Gianluca.
Thank you very much.
While Oscar will try to get in touch with both.
Sure. Thank you very much, Peter. Yes, I was listening with the greatest attention in the previous speeches because, of course, I was working in the past few days on possible considerations and remarks about today's topic. I just want to make sure. Do you see my screen? See if we can do.
Well,
you should see my PowerPoint. Okay.
yes.
Okay, just.
Yes.
All right, thank you. So, okay, here we go. Okay, I was basically thinking about the concept of this expedition proposed by Oscar. I informally call it the Ocean Sky 2023 Polar Expedition. Of course, it's just a name that I gave it to think about the concept. Because I think there are several important, I would say, ideas that come expressed by both Max and Oscar. I was basically collecting ideas from the research experience that I had with work groups of Polar Quest, our own laboratory, GREAL, and the Italian Geographical Society in the past few years. I should specify that I am not a commercial pilot. I have a very limited knowledge of aeronautics, but I do have several years of experience of applied geography research with non-conventional platforms. We basically tested it with several partners in several occasions, technical possibilities of doing research by non-traditional, I would say, platforms, because as geographers, we know that scale is very important, is one of our most basic concepts when we work. We think about geographical phenomena depending on geographical scale, cartographical scale, etc. But we also learned in the past 10 years of work on these issues that you really need to select an appropriate platform to achieve your data and to bring back your research, even though these platforms might not be in the typical standards, in the typical available standards, because sometimes these standards can provide very well consolidated methodologies and processes, but may not give you the exact results, the results that you need. So, given that we are talking about airships, certainly an airship actually fills in the blanks of some research activity envelopes. We are accustomed to see satellite remote sensing and airborne remote sensing by the use of manned and unmanned aircraft. Now, when we are getting very, very close to the ground, now we discovered, and we are very happy of the discovery of drones. Drones are really speeding up a lot of analysis and survey protocols. But airships do really fill a gap, and I will try to explain what I mean in the subsequent images. Thinking back to the discussions we had with Max in the past few days, and thinking about his presentation now, the scenario of bringing scientific research platforms in the Arctic is really, really complex. There are several things that you should keep in mind in planning research activity in the Arctic. I mean, you have this vast, sometimes poorly documented geographical area in which, for instance, the most basic thing you have to deal with when choosing your research platform is ice, for instance. You may get in trouble if there is ice when you do not expect it to be there, or in not having ice when it's supposed to be there. I mean, if you are going by surface, by boat, by land, you have to deal with it. So first of all, a flying platform is first very important response in getting where you're supposed to get. If not at a certain moment, with some time to spare to do a second attempt if you need. And I will not go obviously into the details of the aeronautical part because this was already covered by Oscar. But some data that really struck me when I was thinking about this airship proposal is the cruise speed, the endurance, and the ceiling of the airship. Because this really makes airship a different platform in comparison to other more traditional platforms. We were being shown these beautiful images of these wonderful platforms that allow you to relax and talk and have a chat with other people while flying over the Arctic Ocean in this kind of wonderful and very elegant spaces. But these spaces can also serve very well as a scientific work spaces. And the real opportunity here is not to simply say, no, let's turn this into a scientific research platform, but let's turn it into a scientific research platform without disrupting these concepts. I mean, these spaces can be used for commercial tourist travel and at the same time become laboratories for scientific research. And new technologies allow us to do so. Okay, because if you can stay there to have a talk, to relax, to take pictures, and enjoying this new concept of travel, at the same time you can do active research work if the configuration of the system allows you to do so. I mean, we're talking about a project which is proposing to deliver passengers to, for instance, an advanced camp to the North Pole, and then come back and forth with different passengers and different people. Now, this makes for a very good platform for scientific research as well, because these passengers can be researchers and can bring equipment with them that allow them to do research in these environments by taking a lift, literally, on this very innovative platform. Okay. Furthermore, the fact that these airships can drop and hoist back on board cargoes, this also means that you can deploy instruments and then come back and retrieve them, which is another important concept. So if we think, I mean, if we compare airships with normal standard traditional aircraft, we see that actually givens are gifts because the airship flies slower, may fly lower, can have a longer survey range, and gives you a lot of space and also a lot of lifting capability for several different kind of geographic research applications. Plus, it has a large inertia and big volumes, which are also an asset in this field. I mean, if you go slow, I mean, these are pictures taken by Mike Stroke and Pinioio with a drone in 2018. But it turns out that if you can fly low and slow over an area, you can do very well, especially if you do it periodically, because you can also do environmental monitoring in a very, very effective manner. Because the kind of technologies that are currently available, very small sensor, very efficient sensor, will allow you, for instance, in a simple one-pass flight, to come up with something like this. This is a map, basically, of relevant objects in this case, it's a historically relevant site, but also you can have the representation of an island. Pinioia was documented basically by the work done by Polar Quest expedition with this level of detail. Of course, it was well documented in the Norwegian official documentation already, but the level of detail that you can achieve by using a drone in this case, and you can imagine by using repeatedly an airship, allows you not merely to document how the place looks like in very, very high detail and with very, very high accuracy, but it also would allow you to monitor, for instance, pollution, okay, such as plastic debris, artificial debris, etc., which tend to accumulate in these areas And by measuring the trends of this accumulation, by simply recording data without the paying attention to that, because the system would be automatic, would allow you to have a periodical mapping series of this phenomena with a very short deployment time. I mean, we did this by using drones. It took us a few hours flying the drone and then a few days processing the data after the expedition, because we had to go back to the lab and process the data later on. But on an airship, you do have the space and room and time to process the data on board. And this speeds up a lot many documentation processes that are also useful to protect the environment. Another asset, in my opinion, of using airships is that you have, in comparison to, for instance, some airplanes or helicopters, you have longer survey ranges and longer survey times. For instance, this is very good, very positive, when you are trying to measure phenomena, was geographical position is relevant, but also the timing is relevant. One of the most important research projects in the Polar Quest 2018 expedition was this project involving putting an innovative cosmic ray detector on board of boat Nanook. This was a project led by the several Italian universities under the Extreme Energy Events Initiatives, by the Italian National Research Institute for Nuclear Science, the INFN, basically, and also by the Centro Fermi. Now, these institutions provided us with this device, which was brought to high latitudes and was very effective in measuring cosmic rays. Now, if you're able to load a device like that on a small boat, which is which provides you with a very bumpy ride in comparison to the one you get from an airship, then this means that you can use this kind of device to repeat this important research to the North Pole, for instance, in 2023, on board of the airship. No? So this is the kind of opportunity that you can get out of this innovative platform. If we take the profile that was outlined by Oscar, you can consider that by an airship like this, you can do quite a wide set of remote sensing investigation technologies, but you can also do direct sampling. This is another Nanook 2020 Polar Quest Association picture, in which you deploy the scientists on the place, like Oscar said, let me land there. Suddenly, you decide that the spot is relevant because you notice something that you could not see before. You land there, you deploy your scientists, you make direct sampling, and then come back. Or you deploy automatic equipment and you retrieve that after the research period is over. So there are really a lot of possibilities outlined. Another thing which is important in airships, I mean, you can look on the right side, the early days of my research work. We were trying to do basically aerial pictures in different, I would say, different channels of the electromagnetic spectrum. And we were using several different kind of cameras, but we had an issue with volumes because you put a too much large sensor on board, then there is no room for the operator. Okay, this is not an issue, not a factor for an airship. Furthermore, the airship can go low, that is below the clouds, and look vertically and also get oblique views. This is very important. It is more stable than an aircraft. It gives less accelerations, vibration, etc. And the set of these conditions allows you to get very high resolution pictures. Okay, so virtually an airship doing a leisure or a tourist cruise in the Arctic may also collect the data for scientific research, and without even the crew really taking care of that, or if the equipment is chosen accordingly, the crew is participating actively in using the instruments. So this is a very important option that you have when using that kind of platform. Another picture from the Polar Quest expedition, okay, monitoring ice cover, for instance. This is very important to understand global change, okay? Evolution of climate, factors of geographical conditions in a certain area. And this can conveniently be done by this kind of platform. Plus, as
Let's drive to the end.
Okay, I just two more minutes.
Yeah.
NanoOp 2020 showed us that you can document, for instance, poorly documented areas in Greenland. In order to do that by drones, you have to deploy the drones there. That's why you fly to the place with the airship, you take 3D images of the areas, and you get several different kinds of related data. This is quite important. This is a recent publication from our laboratory. Last slide, last concept. What about wildlife? Because when you are deploying any kind of surveying platform in the area, you have to make sure they do that. Now, airships can document and monitor wildlife in very wide area for a long time, and probably, obviously, discussed, but let's discuss it because it's an interesting element. And probably airships are less disruptive than other forms of research platforms. They might even be less disruptive than drones, for instance, because sometimes drones can be perceived as aggressive entities to animals, whereas an airship is far more predictable, far more, apparently quiet machines. And for instance, the typical burst strike you would risk by flying a helicopter at low altitude in those environments is certainly something which is unlikely to happen with an airship, because flying wildlife would be much more able to see and avoid this big platform. Okay, so these were some ideas, and thank you for your attention.
Indeed, very interesting, and I can't. I mean, it's incredible what can be done with this type of new upcoming technologies. I'll give Paolo the word so we can give up some evaluations of the more, let's say, political, not political, but more historical point of view from the polar areas. Paolo, the floor is yours.
Thank you, Peter. I hope it's not a problem if I speak in Italian. It's okay, but the presentation is in English. Grazie, ringrazio Gianluca, ringrazio Peter per avermi invitato a parlare di un tema che in realtà è abbastanza differente dai temi di cui si è parlato finora, in quanto cerco di capire quale è il ruolo dell'Oceano Artico nell'assetto attuale dei trasporti commerciali marittimi e quale potrà essere nel futuro. Provo a aprire la condivisione. Ok, spero che si veda.
Si vede.
Ok, dunque io parto da un'analisi del perché oggi l'Artico è un oceano, è un'area interessante e studiata dal punto di vista dei traffici marittimi commerciali. Tutto parte dagli anni 90, dall'esplosione del traffico container.
Presentazione, così riusciamo a vedere lo schermo bene.
Tutto parte dagli anni 90, da questa crescita enorme che i traffici commerciali, soprattutto grazie al sistema dei container, a livello globale, e soprattutto l'organizzazione dei traffici marittimi commerciali in un continente, in Asia, nel Far East asiatico. E una direttrice ben che vede diciamo, spostare per la gran parte di questi traffici commerciali verso ovest, quindi nella direttrice westbound che attraversa appunto l'Oceano Indiano. In questa slide c'è la sintesi del dominio dei porti dell'est asiatico a livello globale. Cina e Other East Asia ports hanno sostanzialmente il 71% di quota di mercato nei traffici globali. Come si muovono queste merci? Ecco, queste merci si muovono certamente attraverso le rotte marittime dell'Oceano Pacifico, ma soprattutto attraverso una rotta che adesso andiamo a identificare, che è la rotta di Malacca-Suez del Mediterraneo. Quali sono le rotte alternative a questa fondamentale rotta del commercio mondiale? Sono le rotte tradizionali del Cape Route, di Cape Town, e le rotte che devono essere previste soprattutto in futuro dalla Cina attraverso Belt and Road Initiative e a seguito dello scioglimento progressivo dei ghiacci e delle previsioni di scioglimento ancora più massiccio dei ghiacci artici, anche le rotte polari. Ecco, qui è definita oggi la Around World Route, sulla quale oggi passa il 30% del traffico globale. Questa Round World Route incontra tuttavia dei choke points geopolitici che
embark the ship, the airship, on a nearby field or even a big part in the city where you live in. So, airships are huge, as you know, but they are limited in how many passengers they can carry because to get more people inside the airship. It's because of their weight. So airships are weight limited. Airplanes are space limited. They could probably fit a few more people in the airplanes if they had room for them. However, with airships, if space is abundant on airships compared to airplanes, or even compared to trains, there is more space. So probably you will have your own private cabin when you transport yourself with an airship in the future, with a bed to sleep in and an ensuite bathroom to go with it, actually. So, I'm changing the slide again. Sorry, Max, it doesn't work for me. Thank you. So this is just a funny picture of a futuristic airship, but airships are very slow compared to airplanes. More similar to train time schedules, actually. So it's likely you will be traveling through the night instead of getting up early in the morning. You probably board at night and fly the night train or the night airship. But you will be absolutely sleeping comfortably in your own bed and in your own cabin. And because airships fly slow, turbulence feels more like a soothing wave than like uncomfortable shocks. And because airships fly low, there is no necessity for a pressurized cabin. The next slide. This provides for very large windows, and even the floor can even be made out of glass, because flying low means you will really would like to look outside because you're flying only a couple of 100 meters above. So it'll be a selling point for airlines to have glass for the passengers. So let's say you enter the airship at 10 p.m. at night from a nearby field in Rome. You'll be greeted by the hostess who points you in the direction of your cabin. She will say, "Buongiorno, recto," I don't know, I mix Spanish, but down the hall to the right is your cabin, sir. There will be no crowd or queue to stand in because the entrances to the airship are so many, because the airship is 3 times larger than an airplane of similar capacity, and you don't have any pressurized cabin, so you can make a door every meter if you want, design-wise. That's not really an issue. You can have many, many doors. Why you don't have more doors in airplanes is because they need to be plugged doors because of the very high pressure from inside, right? So it's very expensive and it's very heavy, so you don't want to have many doors. But in airships, you can have many doors. So there's not going to be a queuing. There's not going to be a crowd. So this also means, from a pandemic point of view, that it'll be much safer than any other means of travel to go on an airship, because you can easily keep the distance between travelers. It's likely, actually, that the airship probably has several pickup spots around Rome before heading off to, let's say, England. Because you don't need airports, so you can land in the eastern side of Rome, and then you go north and pick up some more passengers to go actually to where you're supposed to. So when the airship takes off, you will see how the ground just falls away from your cabin window. You can go inside your cabin and you unload your luggage and you put it in the wardrobe and you head out to the onboard restaurant for a supper and a drink in the bar, let's say. And you meet some fellow passengers there, you hear that, oh, well, you know, it's going to rain tomorrow in London. Oh, again. You go to bed, it's 11 o'clock at night. You go to sleep and you have a comfortable sleep for 8 hours. And you still have time to get up in the morning, go to the gym that's situated in the off section of the airship, 2 floors up, then have a shower, have a breakfast. At 8 a.m. you land in London. And by the way, you need to set your watch because it's actually 7 a.m. local time. So let's say the British authorities have granted Hackney Marshes in the northeast of London or Wimbledon Park in the southwest of London the approval of hosting airship landings. So the touchdown will be barely noticeable. Next slide. So you can disembark on the green grass of Wimbledon and walk towards your electrical taxi that's waiting for you to take you to your morning meeting in Westminster, only 30 minutes away. So that could be a future scenario with airships, flying at night, sleeping in your bed, enjoying the ride, meeting other passengers, enjoying the journey, and still have more sleep in your body, more alert when you actually arrive, less stress, less risk of pandemic and diseases because of the distance to passengers. I think it sounds like a good scenario. That's it. Thank you.
Peter, do you hear us? I'm afraid I lost Peter. So
until he comes back, I would like at this point to ask our international institutional guests if they want to say anything in comment to this initiative, this particular webinar, or how it ends the cycle of webinars that we had so far. Hold on. Meanwhile, I have Peter calling me. Okay, Peter just told me that he has a technical problem, so he cannot get back in, probably. He was on a boat, so I figured that it might be challenging to keep the line up. In any case, yes, Antonio, and obviously I would like...
Yes. Yeah, can you hear me? Can you hear me?
Yes, we do, Antonio. Yes.
All right. Yeah. Just first of all, to say hello to everybody of mine on this large picture, and I'm so happy to meet Oscar, Carl Oscar, who was supposed to be in Lauro last year. Is that right, Max? Unfortunately, but that conference is still valid. It is just blocked for this period, but surely we do, hopefully, next year. I was also impressed by a question of Karl Oskar, who said, what is the need to go to the North Pole, he said. This question was also put to Amundsen by an Italian journalist in that for that period, and he said, take care, I tell you what is the reason to go to the North Pole. Take care of the North Pole, control and observe what happens there, because your area, the temperate and Mediterranean area, will surely depend on what happens in the North Pole. And that is true. And we know how true it is. Just this, and together with my regards to everybody, I have been very happy to follow all the webinars and have the pleasure of meeting and seeing all my friends from Russia, and from Norway, and Italy, of course, and I hope to meet you in Lauro as soon as possible. Bye-bye. And thank you.
Ekaterina and Natalia, just in case you want to say anything, we'll be glad to...
Buongiorno, buonasera carissimi amici, siamo molto contenti di essere con voi come sempre e di partecipare in tutti i webinar. Vorrei ringraziare come sempre Società Geografica di Roma e anche oggi Università di Roma per tutte queste bellissime presentazioni che voi fate. Vorrei ringraziare come sempre il nostro amico Antonio Ventre perché ricordo sempre che 5 anni fa in un bellissimo convegno a Roma. Ricordiamo sempre di questo evento. Oggi il tema è molto interessante, abbiamo parlato tantissimo del futuro dei dirigibili airship e questo è un tema molto bellissimo anche per i giovani, per sapere la futura direzione dove noi possiamo lavorare. Storici, ingegneri, tutte persone ed essere una squadra bellissima. Vorrei ringraziare Margaret Twaiten di Norway, grande presentazione che dice che questa è sempre grande. Come sempre vorrei dire ringraziamenti di Peter Peter Johansson, because now I will speak a little bit in English, because he said that when we plan something, it's a very strong job. And when we do a strong job, we will have always success. Also, he said that it's very important not only using history, but talk about the future. And today we talk a lot about the future planning. I would like to thank Max Pinucci, because he told a lot about Soviet Union, about Moscow, and it was a very beautiful presentation. Also, Karl Oskar told a lot about future, and I liked your presentation because you show us beautiful travel, like with panoramic windows, with this comfort. And for us, it's very important because we live in a pandemic, in a pandemic world today, and it will be very interesting. Gianluca told us only to relax and to have this journey, but also to do scientific research works, and it's very important. Not only traveling, but also do something for history. And I would like to tell we must think about future also problems, because quando sto pensando del nostro futuro di questi ships, noi dobbiamo pensare di sistema di controllo, come controllare questi viaggi, perché voi avete sentito che ieri è successo una cosa molto brutta di Kazan, e noi dobbiamo sempre pensare anche di sicurezza, di terrorismo e come si può controllare tutti questi viaggi, come anche avere il visto per fare questi viaggi globali. Questa è una cosa anche fondamentale. Ringrazio ancora una volta tutti voi e tante cuore come sempre da Mosca della Russia. Grazie.
Thank you, Ekaterina. Unless Natalia wants to say anything, we have connection with Bob Boyd, so we could have his presentation if he's available. Bob, do you hear me? Let's see.
Yeah, I got you guys.
Okay,
I
perfect.
Gotcha. Hold on a second. Let me find the spot. So, hold on, guys. Let me get to a spot here. I'm in the midst of another meeting, but this should hopefully work out.
I can present Bob Boyd actually until he gets himself a bit comfortable. So Robert Boyd is a project manager of Lockheed Martin's airship project, and has been for a long time. Maybe you can help me out with how many years?
20 years plus.
20 years plus. And Lockheed Martin is a serious actor in the airship field of new technology, airship manufacturing and certification. And Bob has come with a lots of new insights and understandings in the field of lighted and air technology, which this industry is many times called. So, Bob, if you're ready, I'll stop introducing.
Certainly. Then let's see if I can share my screen out. Let's see. Open the share tray. Let's see. Tell me when you guys can see it.
Not
Entire
yet.
screen. It's not giving me a share button. Why is it not letting me share? There we go. Now it's there. How are we doing? Getting anything
okay,
yet?
yeah, yes, we see you.
Okay. Fantastic. Let me pop these up. I just have a couple of charts that help highlight what I was going to talk about today. You guys asked me a little bit about what has changed in airship technology since the days of the Norge and where we are today. And turns out a lot is the good answer. A lot of good things have changed, and they are quite dramatically different than the days of old. And what those things do is make airships not only safer, which is important, but also they make them, and that capability drives their cost affordability, and that ability is what makes them potentially relevant as we go forward. So let me talk about a couple of the key technology areas that I see as changing in the last 95 years. And then, of course, after that, you can ask me some questions about it. So let me start with materials. Materials area. This is what the airships are made out of, whether it's envelope materials or whether it's the structural materials for the gondola sections, the engines, everything. By and large, materials have gotten substantially better. I think we know that. More importantly, the processes have gotten more repeatable and more safe and more precise, which allows you to build parts much closer to their limits than you were able to 100 years ago. So what happens is the airships themselves can get lighter because the materials are lighter, and there's a very large system level benefit to this big structure getting lighter. In aircraft design, you have to lift whatever the thing is made of. So every pound that you add in structure is a pound you have to lift. So the aircraft or airship gets bigger and bigger and bigger as you add more weight, or you take away payload. So you can either take away payload or you can make the airship bigger. Those are the only two choices if it gets heavier. Conversely, if it gets lighter, you can make the airship smaller or you get more payload. And both of those things are good. So as the materials get better, what happens is the airships get lighter. And there's a really interesting chart I'll lay out here for you. So this is, on the bottom axis is time, and on the left axis is specific strength, which is a technical term, but basically it's how strong the material is for how much it weighs. And over time, materials have improved, and I'll show you the lines. So if you're talking about just bare aluminum or metals in general, they've improved a little bit, not a lot, just a little bit. And if you're in this scale, and composites have come along, carbon composites people are excited about, and they are better, lighter, so that's why they're used. They're a little more expensive to make often, but they're larger, lighter, and stronger. But what's really interesting is what's happened with fabric materials or soft structure materials, which is typically what you make an envelope out of. That envelope that you're making, originally they made them out of rubberized cotton back in the 20s. And that's not a particularly strong material. It was there more as a vapor barrier, air barrier, rather than it was as a structural material. But in the intervening years, we've done a lot to invest in structural materials and their improvement. And what's interesting is how dramatically better they are. So you can see back in 1920, aluminums were much lighter and stronger than the rubberized cottons were, so they were used for main structure. But somewhere around the 30s or 40s, the gas-type fabrics actually got lighter and stronger than aluminums and metals. And it was right around then when airships started getting made as non-rigid. So when you saw in the 30s and 40s, especially in the 40s during the war, those airships were all non-rigids. And the reason they were non-rigids is that the materials were lighter. So you could make a lighter airship than the rigid frames of the original 20s airships. So in time, the materials have gotten even more substantially lighter and stronger. So what's happened is that the largest and often most heaviest component of the airship has gotten substantially larger or lighter than it was even 20 years ago. It keeps getting lighter. So as these hulls get lighter, that means the airships can be smaller, or more notably, the payloads can get larger at the same size. So these materials have done a lot, and the thoughts as to where we're going to go. So these structural fabric improvements make the machine substantially better. And it's, again, 2.5 times stronger than it was 90 years ago. Whereas even composites are only about 2 times, 1.5 times stronger than the aluminums available. So it's a massive improvement in structural strength, and that structural strength improvement allows us to design airships very differently than they were in the past, not only with a non-rigid envelope, but also with a much lighter weight non-rigid envelope. So that's kind of an important area, materials. The second one I want to talk about is propulsion. Of course, propulsion has improved, and I got some data on the Maybach, which was what was used on the a modern engine, a modern diesel engine from my friends at Reglan Engine Development, so Red A03. And you can see the numbers here. These engines aren't exactly the same size, but what you can do in engines is you can create some numbers that sort of align them in terms of their efficiency and their power to weight ratio. So modern engines are certainly more powerful than they were 95 years ago, but it's better than that. They actually also are better at burning fuel. So a modern engine will burn about 20% better in terms of fuel to shaft horsepower than what you get out of an engine from 100 years ago. So that means that to do the same range with the same payload, you're burning 20% less fuel, which means you don't have to carry that fuel, which means you can either make the airship smaller or you can add more payload. So there's a benefit that's better than just 20% by burning 20% less fuel to do the same job. While that's impressive, what's even more is how much the power to weight ratio has changed. So in those 95 years, the power to weight ratio from engines has gone up 170%. So that is a massive change. So the engines themselves are much more powerful, or at the same power are much smaller. So making them smaller makes them easier to integrate, makes them lighter, makes the structure that holds them lighter. Again, systemic benefits by taking weight out of the system. Taking weight out of the system is really good when you're talking about building aircraft. And what's really interesting is that they still burn fuel, much like any other aircraft does. In fact, right now, the only legal commercial aircraft fuels are avgas and Jet A. So it's only two fuels, and they're both hydrocarbon-based. In the future, we're hoping that we'll be able to become a lot more green, and we'll be able to burn hydrogen. And whether hydrogen is burned in an engine or whether it's run through a fuel cell and chemically reacted, it doesn't really matter. The big advantage to that is that now your emissions are only water. So instead of having carbon dioxide and other products that are harmful to the environment, the only thing that comes out the back end is water. So you would be transiting with cargoes, with surveillance missions, with advertising missions, whatever. If you can run on hydrogen, you're producing zero emissions. And zero emissions is always a good answer for the environment and the world. And so why don't we do more of that? Well, I think part of it is just a familiarity issue. Part of it is the fact that hydrogen has one downside compared to other fuels, which is that no matter what you do to it, compress it, or even if you liquefy it, it's still very volumetric for its energy. So compared to a tank of gas, a tank of hydrogen that has the same energy in it is about the size of a truck. So it's very difficult to integrate into ground vehicles or even aircraft because the amount of energy they need is massive. So really difficult to get hydrogen in the system just because it's physically large to store, especially in vehicles that move around. Well, the airship is about the only vehicle that is large enough to easily integrate fairly large storage tanks for hydrogen as fuel. So using hydrogen as fuel for an airship that we're looking at, about a 20-ton ship, you're only using up about 1 to 2% of the volume of the envelope for those hydrogen tanks. So even though they're large, the airship itself is so much larger than those tanks that it integrates well. So you can conceive of how an aircraft that is an airship might be powered by hydrogen, whereas powering aircraft with hydrogen is still a lot harder for longer missions because there's so much energy required that you end up with a very, very large tank, and that's difficult to integrate. So for an airship specifically, hydrogen is a really viable fuel. The extra bonus that happens with hydrogen is if your only exhaust stream is water or steam and water, you have the ability to cool that down and capture some of that water in the exhaust stream. And by capturing the water, you can offset some of the weight loss when you burn the fuel. And for airships, one of their limiting long-range problems is that as they burn enough fuel, they keep getting lighter. And if you get lighter, you eventually can't get back down to the ground. You have more lift than weight. So you either have to vent off some lift gas, some helium or hydrogen, or you have to somehow pick up some weight. Sometimes they picked up water, sometimes they vented off gas, but very long-range missions were always very challenging because of this mass effect. So if you can capture even a small fraction, 10 to 20% of the water that's coming out of your exhaust, the water is substantially heavier than the hydrogen you use to make it because you're combining with the oxygen in the air. So you don't need to capture much of it, and you can actually keep your mass balance equilibrated. In other words, you won't get heavier, you won't get lighter, you can keep it the same. And this is a really important factor for doing very long-range missions, whether you're going to fly long distances with cargoes, doing long-dwell surveillance missions, anything like that. Having the ability to equilibrate the mass is quite important. So that particular factor is really interesting for airships, and that's one of the most interesting future developments on the propulsion front, is possibly going over to a hydrogen future. Next technology area I want to talk to is somewhat obvious, but you really have to think back to 95 years ago to think about how much different it is. 95 years ago, there was no such thing as a computer. There were very few electrical components. What electrical components there were very heavy. So things tended to be done with cables, pulleys, pneumatics, those types of systems which were more familiar at the time, all of which were fairly heavy and prone to breaking down, much more so than electrical components. And the digital side, the computer side, as far as computing and thinking as a machine, yeah, that didn't exist at all in 95 years ago. So from that perspective, we've gone completely away from where we were in the old days of cables and pulleys and hand flying everything. In modern aviation, aircraft are typically flown with a combination of a pilot who transmits the intent of where he wants the aircraft to go, and a computer that augments that capability and helps make that happen. In a modern airship, this is really important, because in a modern airship, in varying and gusty wind conditions, like you might have when you're trying to do something like deliver cargo, a computer has a much better ability to assess what's going on in the environment than the pilot does. As pilots basically respond to their environment with visual cues. Where's my eye moving? Where's the aircraft seem to be moving relative to the ground and the air mass? And then also acceleration cues. How do I feel in my body? I'm feeling the acceleration of a turn. I'm feeling myself being pushed to the side by a gust. You can feel those with both, the body's response, the acceleration cues, and the visual cues. The problem with airships is that they are so large, and those cues are so small, the visual cues change very slowly, and the acceleration cues are so small that you can't really feel them. That in a large airship, the pilot has a very limited ability to see what's going on. And a lot of the time in the old airships, they got themselves into trouble because they couldn't tell what was happening to the airship until it was too late to effect change to save themselves. So the nice thing about modern computers and modern sensors is that those things are both safe enough and available enough and affordable enough that you can put those all over the aircraft. So you have a much better assessment on where the aircraft is moving. Things like GPS, things like INS, very high resolution navigation systems, INS systems, very high resolution sensors for wind and direction. Plus you get weather data and future prediction, all sorts of things that you can do that you didn't do in the past. Those things are all possible now. And because they're all possible now, and more importantly, very affordable now, you can put them on an aircraft. You now can build an airship with a glass cockpit, as you see in the picture. You have the ability to build something that is modern and has the safety mechanisms in place that we're used to in the modern day. And it's really difficult to imagine how risky it was in the day, 95 years ago, to get in that airship and sail over the horizon. I mean, not only was controlling the airship challenging, but you had absolutely no idea what the weather was over the horizon. And today, with the digital flight controls, it really changes how the pilot interfaces with the vehicle. The pilot is no longer hand steering every control. The pilot is now saying, I want to go this direction, at this heading, at this speed, and then the airship actually figures out how to make that happen. So by doing that, making it a digital flight control system, it actually makes it a lot safer. The pilot can focus on what the pilot needs to focus on, making decisions. And the aircraft focuses on the more mundane tasks of pointing surfaces in the right direction, applying thrust in the right direction, all those things that consume the traditional airship pilot's time and energy. And that unfortunately, because of the lack of response, it was also very difficult to do. It required a tremendous amount of skill to fly an airship in a manual mode that now, in modern day, you don't have to have quite as much skill in order to safely operate a digital airship. And that allows you to have more pilots and also have fewer safety incidents, because the likelihood of having a not so experienced pilot in a very difficult situation that can't handle drops, becomes much lower. So the flight control systems is a really big change. This is a major deal in what's happened. And it's amazing that they're not terribly expensive. These things are actually fairly straightforward. Writing the software for them is still a little pricey, but once it's done, it doesn't cost anything to replicate. So these types of systems are excellent, and the NT-07 modern airship built by Zeppelin is an excellent example of it. That airship flies like a dream, can do a vertical takeoff and touchdown easily, even in gusty conditions. And it's all because of the flight control system that's integrated into their vectoring thrust. That combined system is what makes it so safe. So the last thing, and this is probably the most interesting one, is weather and weather monitoring. So in 95 years, the one thing that hasn't changed much is we still have weather. In fact, if you could argue that in 95 years, the weather has gotten slightly worse with the climate change. We have more storms and more severe storms. But there were storms back then, so storms are storms, and they still exist. And it's really amazing to me to think about 95 years ago, you're getting into this airship, and you literally have no idea what's 20 miles away. 30 kilometers, you can't see that far. So 40 kilometers away could be a Category 5 hurricane, but you don't know because there's no way for you to know. So you're sailing out into the unknown just hoping that you're going to be able to see those storms before they get you. That's obviously a lot easier during the day than it is at night. And of course, a lot of the incidents of airships being lost over time occurred where storms came up on them that they didn't predict or didn't know were there, and they weren't able to deal with them either because they didn't see them or because they couldn't actually affect controls to get out of them. So weather monitoring is extremely important. In today's day and age, again, these same digital electronic tools provide us a tremendous amount of insight into what's happening in the weather. You look out the window, you can see far out not only the winds, the wind shears, clouds, cumulus formations, things that are probably going to cause you trouble show up on things like the storm scope here in this picture. You can see that data in the cockpit. On top of it, you can actually have a data link that allows you to bring in real-time, large-scale data from weather centers all over the world that run giant global models of what's happening with the weather all over the world, are updated by actual observations from both ground stations and out of aircraft. So these models are getting much, much, much more sophisticated. And so what's actually happening right now, you can get a really good picture of literally anywhere in the world. Even if you're at the North Pole, you can actually look at the weather map and you can see what the weather should be like outside the window. Much farther than you can physically see. You can see hundreds of miles, kilometers away, so that you can actually see what's happening 6 hours from now or 10 hours along your intended flight path. This is not something that they could do 95 years ago. So you have the ability to see this and affect change, and that's really important information coming back to the pilot. So in the old days, the pilot's job was basically to look out the window every once in a while, but try to fight this aircraft and keep it in the air against any sort of gusting and conditions that happen. Today, the pilot's job is to spend a lot of time looking at the weather and the intended flight track and trying to assess whether he will change the intended navigation path that he has programmed into the computer, and the computer is spending all of its time trying to keep the aircraft on that flight path. The pilot is just thinking about what to do going forward in the future. A much better use for the brain of the pilot than trying to figure out whether his elevator is high enough on the left side versus the right side, and am I going to hit that tree or not? Those kinds of very difficult decisions. He's deciding things that are much more important. And I think probably that last piece that I kind of hinted at, which is this idea of prediction, is completely different than it was 95 years ago. 95 years ago, prediction was, the pressure front is dropping, so we think it's probably going to be stormy. It was not, there's a storm 100 miles away heading this way at this wind speed with these kind of conditions. Today, there are global models running all the time that can tell you not only what's happening today, but they have fluid dynamic simulations that push things out into the future. So you can see what should happen 6 hours from now, 12 hours, 24 hours, even several days ahead. Now, of course, the accuracy of those models gets worse as you go farther away from the time now, but it's getting better and better and better. As the computers get faster, the database gets better. Right now, the variation in weather prediction a day from now or 2 days from now is pretty accurate. If you go back and look at it, maybe it's a couple degrees warmer or a couple degrees colder, maybe you got a little bit more rain, a little bit less rain, but nobody got hit by a thunderstorm they didn't know was coming. Thunderstorms are easy to see, and you can see them coming, and you can almost an hour's accuracy when they're going to get there. So today, you can see the kinds of severe weather that you're worried about, and you can actually get around it or even use it to your benefit. Having a tailwind when you're flying an airship is a really big deal. And this graphic here on the bottom left is actually an example of that. One of the things that we did as we were developing the cargo airships for long haul was we looked at the effects of winds on the airship, because you have to fly fairly low, so that means you're in the cyclonic weather systems rather than up at 40,000 feet where you're largely only in the single line trade winds. So you've actually got to modify your flight path in order to take into account the winds. And so Dr. Sarma actually at SAIC did a lot of work for us on this front. And what's interesting about it is that that straight line on that graph is the Great Circle route from point A to point B. And that Great Circle route is the shortest actual distance. But when you add the dynamics of the airship and you add the wind patterns that occurred over time during have to do, so that weather is moving with time. Every one of those little segments was a new decision the computer was making on the best flight trajectory given the future prediction of what the weather is going to be to get them to the other end. So that flight trajectory, that particular one, was constrained to arrive at exactly the same time. So by taking that longer sort of bumpy route farther away from the Great Circle route, it got there at exactly the same time, because that was the constraint, but it burned about 20% less fuel.